All right, welcome back to Lag Demon Programming. I'm Bill Westlake, and we are working on the compiler design for our dungeon crawl game. And what we're working on at this point is the main language that's going to control the operation of our dungeon, allow us to have an interactive dungeon instead of just a ordinary dungeon. Oh, we could of course import an existing language into our system, and this was brought up by somebody, so I'm going to address it. We could bring Python in here and embed it, or we could bring in any of a number of existing languages. But remember, this is a compiler design course. So why would we use somebody else's language? We're going to develop our own language because that's what we're doing. We're developing compilers. So and we're showing all the different levels of them. In the earliest video, we did a very simple little expression parser, and then we built a command line parser, and then we built a kind of data structure parser, and now we're going to build up a language. So let's get rolling back on here again where we left off. We got some of this stuff with literals done, and we got the expressions done, and we're moving on up the chain here, going backwards through this as we build things up. In order to get this function call stuff doing here, we've got to create several things. So let's start off with our function call node. And let's go over here to our AST. Before we go over that, let's look at what a function call is. A function call ultimately has to be some kind of an R value. You'll see it's an R value, which means that it's going to return a value of some kind that can be assigned to an L value. And of course, an L value can also be an R value. We'll get into that later. But right now, we're dealing with a function call, and we know it's going to be an R value. So let's go over here to our AST, and you see we've got an expression node, and then we've got an R value node. So we want our function call, and we'll call it function call. Am I putting node on the end of any of these? Identifier? No, I'm not. So I do things a little differently in some other things. So this is just a function call, and it's going to be public R value. So function call is always an R value. You can't assign to a function call. Well, there are some exceptions to that, sort of. We'll get to that at some point in time. So let's make this a protected section here in case we need to derive from it, and we'll have a public section. And we need a function call constructor. And what's a function call? Function call is going to have to take a couple of constructors. It's always going to need an ident. And then it's going to take a type. Well, actually, it's got to, that would be its return type. Types, we'll call it return type. And then it's going to take some kind of a parameter list, which unfortunately is below where we are here, so we might have to move this. I don't know if we figure out where. Yeah, parameters are down here, and this is a parameter list, so actually I'm going to put it down here so we can get access to that. So here's our function call. Let me just grab all this and put it down here under parameter list. Because then it needs that's exactly what it needs, is it needs a parameter list. And it's going to have to be a parameter list pointer. And P-A-R-A-M, params. Okay. But this parameter list, it could also be something that takes no parameters, in which case it's going to accept, or it's going to have that unit type as an input. And you see what we said here about a function call. Here's a function call. It can be an identifier followed by a unit, an identifier followed by an R value list, which is these either identifiers or values that are, it's because it's a function call. I'm sorry, this isn't a parameter list. We want this to be a value list, in which case it's going to be an R value list, which can be either identifiers or values that are passed in, or the results of functions. So we need a type def here. We're going to call this this type def is going to be a, how am I doing lists? Are they lists or vectors? I'm pretty sure I'm doing vectors, yeah. So this type def can be a standard vector of type R value pointer, and it's going to be an R value list. And so our function call, because we're going to be passing in R values, this isn't going to be a parameter list. It's going to be an R value list. There it is. That's going to be a pointer of those, and we're going to call these arguments. And so if this is null, then we want our parameter list type. If it's let me rephrase that. If we specify in the parser that it's taking a unit in, which is what distinguishes an identifier as a function call, then that unit just means that the R value list is a null pointer. So the R value list can be a null pointer. So let's go up here under protected. We need an identifier. We need a return type. Actually, the return type will be defined by the function. We don't need a return type. I'm sorry. Confusing myself just a little bit. We need arguments. We did an R value list pointer called args. And so we can just assign this here, underscore ident, underscore args, and if that's null, we don't have anything to worry about there. We need these two methods. We'll get rid of this for the moment. We'll just output the ident and then we will so we'll output the ident and a space, and then we'll go for auto. Well, we'll start off by if underscore args does not equal null pointer. We'll go for, and I'll be a little bit more precise here. Do this. We'll go for auto arg underscore args, and we know that that argument is going to be an R value, and we didn't set up R value to do anything. So R values are expressions and expression. All right, so yeah, our function call, yeah, we'll just print it out like that for now. We may have to go add something into the, because this is an R value list We probably have to tell R values how to print out an R values an expression. We can just let it fall to the expression to handle that. Well, and an expression doesn't have one either. So, yeah, we're going to have to add it at least to we don't know what an expression is here. It's too abstract. We'll probably have to fall to something like a node, being able to at least print. Oh, that's right. Yeah, we probably have to do a little refactoring here because virtually everything has something that it can print out. Node.out.os calls that. So let's see if this compiles as we've done it here. Oh, that's not the terminal. Bring up the terminal, go into build, make, might have a problem with it. Redefinitive class function call. Did I already do a function call? I did one all the way down here. We'll just delete this. I never got finished with it, I guess. All right, let's try. Okay, that's working. So now we can go over here to our parser. And when a function call is a unit, fun call needs to be function call type. Make sure I didn't already define it. I did not. So we'll go, well, we'll have function call pointer. We'll call it fun call, func call. That's fine. Percent type. This is going to be a func call, and it's going to be a func call. Is that the right one? Did I call it func call? All right, I call it fun call. I should change that. Make this also fun call, just for naming consistency here. They're two different scopes. They're two different concepts. So this type in here doesn't really interfere with this name here. Fun call. Okay, and then we can go that an R value, well, it is an R value, so we should be able to do so an R value is ultimately an expression. We've got an R value type for it, and we've got it here as well. So we should be able to do for this, we should be able to go $$ equals $2, because it's a function call. Here we should be able to go $$ equals new. We already had R value list here. R value function call. What's an R value list? It's not defined yet. We've got an R value list here. We have to define it. Percent type. Oh, we've got to define it up here first. I put R value list pointer is an R value list, and then if we come down here and go R value list, R value list, then we should be able to go new function call $1, comma $2. And then when it's a unit, however, we're going to say $$ equals new function call $1, and we'll just pass in null pointer because there's no arguments to it. Try a make, and it made, it built. So now we know what a function call is. We don't yet have, well, we do have the R value and an R value list. And an R value is wherever it came from, so it's going to be that $sign equals $1. Now this is where we have to go that an R value list. Oh no, if we just get in, first time we get an R value, we need to go new R value list, and then $sign pointer push back $1, put it in the list. Okay, confusing myself there a little bit. Now we can just go $sign equals $1, and then $sign pointer push back $2. Oops. Let's see if this builds. And that built. So we're almost there. We can just pass these through. $sign equals $1. If we've lined our types up right, these should all pass through. It gets easier as you move up in abstraction, which is what we're really doing here. Just pass those on along, make sure for certain that that compiles. We didn't miss any types, okay. An identifier, an L value, is going to just be that, so it's going to be $sign equals $1. So now we have this idea of a statement list, which is these lines. So we still have to do the let statement piece, and then all the rest of them should fall into place. And yes, they should just fall into place, because then we have a statement list. So let's go back here and check out our AST, and we've got all of our expressions done. Now we need to do this let statement. So let's do a class we'll call let statement, which is how we define a function. It's of type FNG node. Actually, I am going to leave that there, and I'm going to continue, because we're right about 30 minutes now, pretty close. I'm going to continue the let statement in the next video, and we will hopefully be close to finalizing this bit of the language. Now, there's some other features we're going to have to add to this language, but I want to get the basic concept working, get our visitors working on this structure with expressions, let statements, and so forth, the ability to perform these functional operations before we start adding in certain data structures. And we've got a series of data structures, fundamental data structures, that we need to add in, and those two, and I'll discuss those in upcoming videos, so that we can actually use different kinds of data in this. And then there's some additional constructs that we're going to need to build for working with those, but this will allow us to get something that compiles and looks at some actual code that we're going to write, and turns it into an abstract syntax tree. And then we're going to create a little visitor that's just really going to walk through it and verify a bunch of things, check some things out, and generate errors as necessary. So thanks for watching. I hope you enjoyed it. I hope you got something out of it. We're moving along a bit at a time here, but if you liked it, hit that like button. If you really liked it, hit that subscribe button, and I will see you in the next video. Thanks for watching.